Okay, welcome class. In this class we will discuss about the how to determine the optimal value of a performance index. In the previous class we have discussed about the salient feature of matrix Riccati equation, as well as we have also discussed what is a sufficient condition in which we find if del 2 h by del u square is R and R is positive definite. So, my matrix del 2 h by del x square, del 2 h by del x del u, del 2 h by del u del x and del 2 h by del u square must be a positive definite. With respect to a linear system, if you will see, my this value is q, these off diagonal values are 0 and this value is r. So, my this matrix is positive definite, as q is a positive semi definite and r is positive semi definite. So, we can say if we have del 2 h by del u square a positive definite, this means we are minimizing the performance index in solving the optimal problem. So, if we will see how to find out the optimal value of the performance index, my problem here is I have a system x dot t as ATXT plus BTUT, and I have to find out the optimal u which will minimize my performance index, which we defined as half of XTF f of TF, sorry, x prime TF f of TF x of TF plus integral T0 to TF. It is my finite time regulator problem, and this is x prime qx plus u prime ru dt, and half we use here for our simplification. So, my objective is to determine the optimal value of the u which will minimize the performance index given by jx t0 t0 with, so my optimal u which we have find out, that is minus R inverse B prime PT XT, where PT is the solution of my matrix differential Riccati equation, which is, so matrix differential Riccati equation is what? That is P dot T is given as minus so we write it in a different way. Let's write a simple equation directly. P dot T plus A transpose P plus P A minus PB R inverse B prime PT plus qt equal to 0. This is my matrix differential equation. So, this is my optimal u. To determine this u, I require p, and p can be found out by the solution of given matrix differential Riccati equation. So, in today's class my objective is, with these values, what is the, I want to determine J. So, to find the solution of this equation, this problem, we just consider d by dt of x transpose t pt xt into dt. What we can write for this? We can write for this, because dt will be cancelled out. So, this is d of x transpose t pt xt with the limit t0 to tf. So, this is x transpose t pt xt, which can be written as your, sorry, this is t0 to tf, x of tf, p of tf, x transpose of tf, p of tf, x of tf minus x transpose t0, pt0, x of t0. So, this term will have these two values. So, in the given performance index, so this j I am writing in a different manner. I am writing j xt0 t0 as, I am adding this term x transpose t0 pt0 x of t0 and say I am writing this half plus 1 by 2 t0 to tf. This term I will write as such x transpose qx plus u transpose ru, and I am adding this term d by dt in this relation. So, I am writing this, and in this we are adding d by dt of x transpose px plus d by dt of x transpose p x dt. So, now what this will have, if I will expand this integral, so this will give me x transpose of pt xtf ptf xtf. This term will be cancelled out, and ptf is nothing but my f of tf. So, j written in this form or written in this form is the same value. This j written in terms of the x prime f x tf I can also write in this given form. So performance index we can write in this form here. So if I will expand the integral of d by dt of x transpose t pt xt, this term will cancelled out and I will left only with the x transpose tf ptf x of tf, where ptf is nothing but my f of tf. Now to determine the value of the j, we have to evaluate what we will have in this integral. So we will separate out the term of the integral. Let's first see what is the value of x transpose qt xt plus u transpose ru. So here u we can write as, so we can take UTS minus R inverse B transpose PT XT. So if I will take U this, so value of this I can write as X transpose of T QT plus, if I have to take the transpose of this, so X transpose will be the first term, then P B R inverse. So this will be my X transpose I have taken outside, so this will be nothing but P B R inverse for the U transpose. X we have taken on this side, this RT, then UT, again directly I will write this. So R inverse B transpose PT and this I will write within this bracket. So this is equal to this one. In this one R will be I. So if I will this is nothing but my identity matrix I. So I can write X transpose T QT plus P B, only one R inverse is left out, R inverse B prime PT XT. So the first two term X prime QX U prime RU I can write in this form, QT plus PB R inverse B prime P. Now if I will expand d by dt of xt transpose pt xt, this is nothing but my x dot transpose t, sorry, pt xt plus, so first term I am taking the derivative of this, second taking the derivative of p, this is p dot t xt, and the third will be plus x transpose t Pt x dot of t. So d by dt of this can be written in this form, and here what is my x dot? If we will see, x dot of t is at xt plus bt ut, where ut is r inverse b prime pt xt. So this is nothing but at minus b r inverse b prime pt x of t. So this is my x dot t. So I will place my x dot t in the first and the last term. So this I can simply write as, in place of x dot, so if I am taking the x dot transpose, so this I can write as x transpose of t, because I have to take the transpose of the whole term. This whole term means x transpose plus, multiplied with the transpose of second term, and the transpose of this term is a transpose t minus the transpose of this term will be, once we will transpose this, so my first term comes out to be pt is symmetric, so its transpose remain the same, b transpose will become b, r again is symmetric, remain same, and b will become the b transpose. So this is my x dot transpose multiplied with pt xt. Second term I left it same, x transpose t p dot of t xt plus the third term x transpose of t pt, and in place of x dot t I will place the value of this x dot, which is at minus b r inverse b transpose pt and xt. Now in the next term we will write the whole expression in between x transpose of t and last xt. So I will take x transpose of t from here, so this is left by, and p we are multiplying into this in the first equation, this is a transpose t pt minus pt b r inverse b transpose p. So by expanding this I will got this x we will take some outside the bracket. So by expanding the first term we got this, from here we got only the p dot of t from the second term, plus from the third term x transpose taken outside, p I will multiply plus p A and minus P, PB R inverse B transpose PT, and last term will be my XT. So if I will see my first two term are in terms of the X transpose X and d by dt term, I am also writing in terms of X transpose of X. So to get the integral second term, so now what I can write for this J? Now what I have to do? I have to add this term plus this term with dt. So once we will add these two terms, so we will get J as, my first term was 1 by 2 x t0 pt0 x t0 transpose of the first term plus integral t0 to tf, and these two term I have to add, and this I am adding in this way, x transpose of t I will write here from the first two term I will have qt plus p b r inverse B transpose P. So I am getting this term from here, and from here if I will see plus A transpose P, once I will add, so this will be the 2 times twice of P plus I will write first this as the P dot, next term will be A P, which I am getting from, this will be PTAT P A and minus 2 P B R inverse B transpose PT and XT dt. So if I will further expand this, so now you will see this is the 2 PBR inverse B prime P, PBR inverse B prime P. So in a way what I can write, I can remove this and this I can make as minus, and I can write this into dt. So now what you see, what I will have in this, P transpose P dot T plus A transpose P, PA minus PB R inverse B prime P plus QT, and this is nothing but my matrix differential equation which value is 0. So whole this value is nothing but 0. So half PT0 XT0. So I will get J optimal value of performance index is nothing but half of x transpose T0, PT0, XT0. So what we have done, once we will see, we have taken the d by dt of this, expanding as x transpose T0, PT0, XT0 with condition that P of Tf equal to f of Tf. So this means if I will replace this, so this is showing me nothing but my terminal cost. In my performance index, I am substituting, I am adding this half of x transpose T0, PT0, XT0 and including d by dt of x transpose Px into the integral part. By expanding this, as we have seen here, we got nothing but half of xt0, pt0, xt0 plus half of x transpose q plus a transpose p, pa minus pb r inverse b prime p plus p dot xt. And if you will see, this is nothing but my matrix differential Riccati equation, which value is 0. So my this whole term will become 0. So I am left with the initial cost as jxt0, t0 as half of x transpose t0, pt0, xt0. So this expression gives me nothing but my optimal value of the objective function. Now as we have solved this from t0 to tf, similarly I can solve it from t to tf for any intermediate point. So if I am solving it for t to tf, my optimal cost will be x prime t, pt, xt. Because t is varying from t0 to tf, even I can also express my optimal cost as half of x transpose of tf, ptf, xtf. So by this we can determine the optimal value of my objective function, and as my second variation is 0, r is positive definite, so this means this optimal cost is nothing but the minimal cost of my performance index. In the next class we will start with the infinite time LQR system. So I stop my discussion for this class here. Thank you very much.